Hey friends, welcome back in another video with the detailed project that we have a major project on our assemble techniques. So basically we have two domain here, or we'll be discussing with two parts of the project with different domain. One is telecom and another one is IT. So let's start with the telecom first. So again we have as usually we have come with steps and the solution respectively. So the context here for telecom is a telecom company wants to use their historical customer data to predict the behavior to retain customers. So you can analyze all relevant customers data and develop focused customers retention program, right? Here we have data description, that is each row represent a customer. Each column contains customers attribute described on the column's metadata. So the data set includes information about customers who left within the last month. So the column that we have here is churn. Secondly, services that each customer has signed up for: phone, multiple line, internet, online security, online backup, device protection, tech support, and streaming TV and movies. Then customers account information: how long they have been a customer's, contract, payment method, paperless billing, monthly charges and total charges. Then we have demographic info about customers like gender, age range, and if they have partners and dependents. So overall our objective of the project is that to build a model that will help to identify the potential customers who have a higher probability to churn. This helps the company to understand the pinpoints and patterns of customers churn and will increase the focus on strategizing customers retention, right? Steps data understanding. So here we are importing all the necessary library, so you will see how we have used them, right? So you can use at the same time, and at last you can collect them in one cell. Okay, so this is for displaying or HTML, right? So we are importing output PNG. So they basically, this is a style we will be using with our Python. So hope you got the idea how we import or how we use inline CSS with our project. So the very first step is that read customers churn one.csv as a data frame and assign it to a variable. Similarly, we have another CSV and import it and assign it to another variable. So we are importing it and storing it into different variable, right? So first one is df1.sample. so here we are getting one sample. Then you can see that customer ID, gender, citizens, partners, all the information about our data frame. Then we are getting df1.shape. so it is 7043 rows into 10 columns. df2.sample, customers ID, online backup, device protection, tax support, so on so forth. So all the sample of the df2, right? Then we have df2.save. so we have 7043 rows and 12 column. C is merge both the data frame on key customers ID to form a single data frame. So here df equals to pd.merge, right? df1 df2 on customers ID. And here df.sample. so again we are defining our sample here. So you can see that the sample we have. And if we check df.shape now, to 7043 by 21. If we check df1, df2 and final df save, so you can see that 12, 10, 12 and 20 accordingly, right? So this was after merging the data set. Now D, it is asking that verify if all the columns are incorporated in the merged data frame by using simple comparison operator in Python. So df1.shape1 plus df2.shape1 minus 1 equals to df.shape1, right? So this way we will check that, okay, if it is returning true, that means both the data frame have same data set, right? Then we are second step that we have is data cleaning and analysis. So A is impute missing and unexpected values in the data frame. So first we are checking if there are any duplicate, right? So df dot duplicated dot sum, so there are 0 duplicate. Df dot head, so here you can see we will get the top 5 rows in our data frame. Then B is create a function that will accept a data frame as input and return pie chart for all the appropriate categorical features. Clearly show percentage distribution in the pie chart, right? So here we are having a cx equals to df dot gender dot value counts, then ax dot plot kind equals to pi, right? Auto pct we are giving 0.0, that means up to one place after decimal. Okay, and ax dot plot, so here you can see that the female, male and the gender ratio we have 50% each. Then ax equals to df dot churn value counts, right? Ax dot plot kind equals to pi. Auto pct again the same thing. Here we have churn, yes again for male and no is again for female. So churn that you can see in the case of female it is 27%, which is very less as compared to the no, that is 73%. Then what we are doing is we are taking the df dot total charges, right, and replacing our spaces with 0, right, and converting the same as type float. So here you can see that how it has done. Now df total charges equals to np, where df of total charges equals to 0, df of total charges dot mean, df equals to total charges. Now we are getting df dot head. So here you can see if we get the head after performing this operation where total charges equals to 0, then take mean, otherwise take the simple total charges. C is encode all the appropriate categorical features with this best suitable approach. So here we are defining a plot, right, plot by function where we are taking a data frame, converting into a data frame again, and I call in enumerate in the df columns, that for all the columns. If df columns dot d types equals to object, right, and columns not equals to customer id, we are ignoring basically the customer id here with this condition. Then df temp call equals to df call. Okay, abc equals to df call dot value counts, and plt dot pi of abc auto pct up to 0 floating, and labels equals to df dot temp value counts and index, right. Then plt title we are passing column, b box we are giving face color as 0.9, and padding we are passing as 5, and finally plt dot show. After that it will print the hyphen around 100 times, right. So here you can see the gender, partner and dependent, and with each iteration there is hyphen printed, so because this is in a loop, so this way it will plot for every features, right. You can see that for contract, paperless billing, payment method, churn. Okay, now at the last we are using encode features. So here we will encode the features now, this one, the final step, right. So le dot label encoder we are calling the function for I column in enumerate df dot columns. If df call dot d types equals to object, and again column not equals to customer id, then df call equals to le dot fit transform df call and returning the df. So df new equals to encode features df. Now D is split the data into 80% train and 20% test. So df new dot drop function we are calling customer id in place equals to true, x is equals to 1. So x equals to df new dot drop churn, x is equals to 1, y equals to df new churn, right. X train x test, y train y test equals to train test split, xy and test size equals to, here test size we are passing 20%, that means remaining 80% will be used for train size. Now E is normalize, standardize the data with the best suitable approach. So here yeah, this one. So here the scalar, that is standard scalar, we are importing it, and sc is equal to standard scalar, then xtrain equal to sc dot fit transform for xtrain, similarly for xtest, right? Then rf, that means we are again calling our random forest classifier for decision tree. We can say rf dot fit equals to xtrain ytrain, right? So this way we will fit our xtrain and ytrain. Now train prediction will be our rf dot predict xtrain, and test prediction will be rf dot predict xtest, right? Then printing classification report as ytrain train prediction. Okay, printing classification report as ytest test prediction, and you can see the train classification report and test classification report with precision, recall, f1 score. So here you can see that we got up to 100% of precision in both the cases, but here nearly 83%, 64% for 01, and similarly with other factor as well. Third is the model building and improvement. So for first step is train a model using XGBoost, also print best performing parameter along with the train and test, right? So here we have percentage time, right, to get the time. Then model of xg classifier parameter, we are passing now learning rate uniform 0.05 to 1.1%, 0.1, subsample uniform 0.2 to 0.3, then n estimator minimum child weight, regular alpha, regular lambda, call sample by tree, max depth, right? So here you can see we are defining the random search function, randomized search cv, model parameter distribution equals to parameter, nitr equals to 30, n jobs equals to -1, scoring accuracy, return train score is equals to true, and then random search dot fit function we are calling xtrain ytrain, then print best score of randomized search over 10 iterations, so random search dot best score, right? So here you can see that how we got the best score of randomized search over 10 iteration is 80%, right? And the wall time is 6.3 second. Now for kb in random search dot best parameters dot items, printing best value for 0 is again format of this kb. So here you can see that in every iteration best value for call sample by tree is 0.63, then best value for learning rate is 0.14, best value for max depth is 5, best value for minimum child weight. It is iterating actually with every these parameters that we just have defined, right? So and we are getting respective value for them. Now second part is improve performance of the XGBoost as much as possible, also print best performing parameter along with the train and test performance. So again we are doing the same thing to improve all the parameter, right? We have defined them, then we are getting the same thing, and this time with the iteration of the same values. So you can differentiate them, right? How accurate you are getting when you improve your parameters, right? So yeah, we will see further. That is rs prediction, that is random search dot predict xtest, right? Print classification report ytest and rs prediction. So this is for classification report for random search, and this is for grid search, right? So we have applied on both. So here you can see if we talk about precision 85 61 85 69, recall 91 55 92 53, and f1 score 82 61 88 60, right? For 0 we can see that the highest value and the accuracy here we are getting 0.82 and 0.82. that means there is not much different, but you can see with a slight difference in this value, right? 68 55 61 and so on. So this was all about part 1. Now let's forward to part 2. So part 2 is basically based on information technology domain. So what the context is, the purpose is to build a machine learning workflow that will work automatically irrespective of data, and users can save efforts involved in building workflow for each data set. Project objective is build a machine learning workflow that will run autonomously with the CSV file and return best performing model. The first step is build a simple ML workflow which will accept a single CSV file as input and return a train based model that can be used for prediction. So here we can also use our last CSV file as well, right? So that is also useful here. So let's define the function that is pre-processed data path to CSV target feature, then df equals to pd.predict, right, CSV path, right? So here we are defining this. Now imputing missing values, so missing values equals to df dot is na dot sum, then missing list, missing values is greater than 0 dot index, then convert that to list. For I in missing list, if df I dot d types in these one, right, df dot fill na df I dot mean in place equals to true, then else df of I equals to fill na mode of df I 0 0 in place equals to true. Now impute duplicate values, so here df dot drop duplicate in place equals to true. Impute necessary features for column in df dot columns, unique percentage df dot call, df of call, right, dot value counts dot counts divided by df dot shape 0 multiplied by 100. If unique percentage is greater than 95, df dot drop column in place equals to true, access equals to 1, else pass this, right, simply. Now return the df and the target features, so it will return the value from here. Now let's create a separate function for various purpose, like to get performance of all the models. So first we are defining our main function, that is train model, right, and let me erase this. Here we have initialized the variables, right, all these variables that we gonna use. Now encode the variables with object type. So this is the formula, this is the method for call in pre-processed df columns. If processed df call dot d type equals to this symbol, that is O, then pre-processed df call equals to le dot fit transform pre-processed df of that columns, right, else just simply pass the loop. Now split into xy, so x is preprocessed df dot drop, so we are dropping the target features x is 1 and remaining features will be in x, and y will be preprocessed df target features, right. Split into train and test, so x train x test, y train y test equals to train test split, xy test size equals to 0.2, random state equals to 22. Initialize model, that is lr equals to logistic regression, dt equals to decision tree classifier, rf equals to random forest classifier, xgb equals to xgb classifier, right, ada boosting classifier, model list lr dt ada xgb, all these. Okay, now iterate through model, so we have to iterate here, train and measure performance. So defining a for loop in enumerate model list I dot fit x train y train, train prediction I dot predict for x train, test prediction I dot predict x test, right. Then train accuracy score y train and train prediction, test accuracy score in y test and test prediction, then test precision score of y test prediction average equals to weighted, and test recall score y test prediction average equals to weighted. Now update model performance into a data frame, so model lst dot append I, then train acc list dot append train acc, then test acc lst dot append test accuracy, right, then test prediction first dot append test prediction. So this way we will perform all these operations, and in the column names we are taking models, right, train accuracy, test prediction and test recall, and in model performance we are doing the whole zipping here, right, so it will zip on the basis of the columns equals to columns name. Now pickle file should be saved for the best performing model. So yeah, basically pickling is used for whenever you You don't need to rebuild your code again, right? Your model again, you just pickle your code or the model, and next time you directly use it. So let's make a function to pickle the model with the best weight. So pickle model best performance, we are getting it from here, right? And then xtrain ytrain file name, best model equals to model performance. So model performance, that train model performance of train accuracy equals to max of model performance of train accuracy. Then take model dot ilog of 0, right? And similarly best model dot fit will be of xtrain and ytrain with open file name wb as handle, pickle dot dump best model, handle dot handle protocol, pickle highest protocol, right? Now main function to call the pipeline is defining main function path to CSV target feature, pre-processed df target feature, pre-processed data path to CSV target features, right? Model df xtrain ytrain equals to train model, pre-processed df and target feature, pickle model, model df xtrain ytrain and model dot pickle. So our model will be saved like in this format, and finally it will return the model dot df. So let's call the our main function for pickling. So perform df equals to main function, we are passing our CSV here, right? And passing the target feature, that is online security. Okay, so here once you do that, you will get your final model in this perform.df. So if you call this, you can see that we applied logistic regression. Train accuracy we got 0.78%, test accuracy 0.77, or this train accuracy 78%, test accuracy 77%, test precision 76%, test recall 77%. Similarly we got that with decision tree classifier. Similarly we got when decision tree classifier max depth was 1, right? And we also applied the same with xgb classifier. So this way you can pickle and get the final prediction for your verification or next time, or you can directly export this file as model.pickle. Yeah friend, this was all about the assemble technique projects. Hope the concept that have been covered in assemble techniques are really useful, and the product and the project concepts are also in your favor. So thanks for being with us. We will come up with another content. So all the best. Thank you.